Alright, we're going to talk about solving inequalities. An inequality is something that's unequal. It means it is not equal. Something that may be a little more familiar to you are the signs greater than and less than. Hello. Alright, just to review, whenever you have a greater than or less than sign, the open part, the one with the space, is always facing towards the bigger end. The side with the point is always facing towards the smaller end. You may have seen someone draw the little crocodile. I've been having complaints that people don't get to see my artistic abilities this year so much, so here you go. The alligator wants to eat the big meal, so it has its mouth open towards the big side. Okay, let's do some quick illustrations here. We could say simply, let's say 5 is greater than, that bigger side's open toward it, 5 is greater than 2. And if we look at the number line here, if we had our 0 here, we'd have 2 here, we'd have 5 somewhere up here, and clearly the 5 is bigger than 2. We could write the same thing, saying that 2 is less than 5. Both of these would be giving you the same message. We could do some more. We could say negative 5 is less than 20. We can say 1 is greater than negative 2. We can say negative 7 is greater than negative 8. And we can keep going and going and going. Just remember, the small end is always facing towards the small number. The big end, the big alligator mouth, wants to eat the big number. It's facing towards the big number. You can always draw yourself a number line, and remembering as you go towards the right, the numbers get bigger and bigger and bigger, and then as you go towards the left, numbers get smaller and smaller and smaller. So on our number line, if it's further to the right, we know it's greater than. One last thing, remember, if you have a greater than or less than sign with a line underneath, it means that value is included. So you might say something like 9 is greater than 8, but we can also write 9 is greater than or equal to 9. That's true since it's equal to that value. So whenever you do have this line underneath, just remember that value is included. It's also equal to it. Alright, so your assignment is going to be asking you to solve and graph the solution set. We can use our same basic rules that we have from solving equations. The only difference is, instead of an equal sign, we're going to have either a greater than or a less than sign. Let's take 7x minus 5 is greater than 6x plus 4. So if this was an equal sign here, not a greater than sign, well, we'd first want to put our x's together, so that's not going to change. Let's go ahead and subtract 6x to this side. That's going to give us x minus 5 is greater than 4. Now to get x by itself, we need to add 5 to both sides. That's going to give us x is greater than 9. Okay, so now we have our solution set. X is going to include all the values that are bigger than 9. Remember, there's no line underneath here, so we know 9 is not included. It's not greater than or equal to, it's just greater than. So anything bigger than 9. Alright, so if we wanted to graph our solution set, we can do that right on a number line. I'm just going to put my 9 in the middle here, so we know to the left would be 8, 7, and all the smaller numbers. To the right would be 10, 11, etc., etc. We're not going to be including 9 So we're going to have an open dot. We're not going to shade it because it's not greater than or equal to, it's just greater than. And since we have greater than, we want to shade all the numbers that are going to be bigger, which are going to be the numbers to the right. And we have our graph. Alright, pay close attention to this. This is the only time, this is the only rule that's different than solving normal equations. Let's go ahead and say, alright, how about 5 is greater than -1. Alright, we all agree 5, if we had our number line, 5 would be up here, -1 would be somewhere down here, and we could say, alright, yeah, of course, 5 is greater than -1. Alright, let's say we take that same inequality and we multiply both sides by -1. So times -1 times -1. Now, instead of maintaining our greater than, we're going to flip our sign, since we multiplied by a negative, to a less than. So now we have -1 times 5 is -5 is less than -1 times -1, which is +1. And of course -5 is less than -1. So flipping our sign worked. Okay, let's do another example. Let's say we had -0.25. Y is greater than or equal to 2. Okay, just like what we would do normally, let's go ahead and divide by -0.25, divide by -0.25. Since we divided by a negative, we know our sign is going to flip from greater than or equal to less than or equal to, and then we are going to have y left over here. These 0.25s are going to cancel out, and we'll have less than or equal to, and this is going to give us -8. So, of course, if we wanted to graph this, we give ourselves the number line. Let's say -8 is somewhere over here, so to the right would be -7 going this way, -9 would be going this way. We have a less than or equal to, so we know our answer is going to be including the -8, and then it's less than, so we're shading to the left. And there's our answer. Alright, and that's about it. One more example. One more example. What? One more example? Okay. If you insist, let's say we had -m is less than or equal to m plus 4 all over 9. Okay. We're just going to continue on doing the same thing we would normally do. So first, I see this 9 in the denominator that I want to get out, so I'm going to multiply both sides by 9. That's going to give me -9m, and I multiplied by a positive, so even though this m is negative, since I'm multiplying by a positive 9, my sign is not going to flip, so I'm still going to have less than or equal to, these 9s are going to cancel, m plus 4. Okay, going from there, I need to get my m's to one side, so I can subtract m. That'll give me -10m is less than or equal to 4. And finally, from there, I'm going to want to divide by -10, divide by -10. Now I did divide by a negative, so my sign is going to flip. So now I'm going to have a greater than or equal to sign. My -10s are going to cancel. I'll get m is greater than or equal to 4 over -10. And make sure you still remember how to simplify fractions. We want to simplify things always. This is going to become m is greater than or equal to -2 over 5. And if we wanted to graph that, we can just put in a -2/5. I know going in this direction, I'll have 0 somewhere over here. I have that equal to sign, so I know it's going to be shaded in. and I'm greater than, m is greater than, so I'm going to be shading to the right, and we've got our answer. Alright, a couple quick things before I say goodbye. If you're ever solving an inequality and you end up with the variable on the right side, let's say you had 5 is greater than m. 5 is greater than m. Be very careful when you're graphing something like this. We're still going to have our 5. To the left we might have a 4. To the right we might have a 6. Same as always, there's no equal to sign, so it's going to be an open dot. We're not going to shade it. Now, 5 is greater than m. What numbers can we put in for m? Well, we want numbers where 5 is bigger, so we might say 4, 3. Notice, we would be shading to the left here. If we shaded to the right, we would be saying 5 is greater than 6, which is no bueno. So, if you ever have the variable on the right, and if that's confusing to you, you can always flip it around. So 5 is greater than m. We can also say that m is less than 5. Notice the small end is still pointing towards the m. The small end here is still pointing towards the m. So it's the same thing. It's just a little easier to visualize when we're graphing. So a quick recap. When we're solving inequalities, we're going to be using the same rules as if we're solving equations. The only difference is if we divide or multiply by a negative, remember to flip that sign. So less than will become a greater than will become a less than, etc., etc. Also, if you have a greater than or equal to, a less than or equal to, that's including the value. So remember, you're going to graph that with the closed dot rather than the open dot.